1.4 perimeter and area in the coordinate plane. So you have a couple essential questions. How do you find the perimeter and area of a polygon in the coordinate plane? And how can you tell if lines are parallel or perpendicular using their slopes? Okay, so starting off, we're going to go over some formulas later on about how to find like the area of a trapezoid or the area of this hexagon. But right now, really simply, you can always find the area of regular polygons, or actually pretty much most polygons, by dividing them up into familiar shapes. So we can, for example, divide this trapezoid into a rectangle and two right triangles, right? So if I were to draw a couple of heights here, then if you knew more information about this, well, I'd have two right triangles. Maybe I would know what the height was. Maybe I would know what this length was. Maybe I'd know this middle piece. And I could basically find the area of this rectangle, the area of these two triangles, and I'd be able to find the area. So with hexagons and other shapes with multiple sides, as long as they're regular, usually we can divide them up into equilateral triangles. So what I mean is, like, you'd find the center of this thing, and you could actually divide this up into equilateral triangles. So let's see, let me draw one of them. So if I could do that for every single side, I'd come up with, let's see, there's 6 sides in a hexagon, so I should come up with 6 equilateral triangles. So you don't truly need to know how to find the area of every single figure out there. What you can do is, just by knowing how to find the area, for example, of a triangle, you could then, well, I didn't do that great of a job. Let's just pretend like they're equilateral. Let's also pretend that this is a regular polygon. Regular meaning that all the sides and all the angles are congruent. So if we just pretend that each one of these triangles are exactly the same, then if I knew the height of one, and you'll be able to figure this out, I'll show you this probably more in trigonometry than in geometry, but if you could find this height, and maybe you could because you'd know some of these angles because they'd be regular, it's a regular polygon, you'd know some of these angles, you'd be able to calculate what the angles are, what the height is, you'd probably know what one of the sides is, you'd be able to find the area of each triangle, or one triangle, and then multiply it by 6 and get the entire area. So just an idea of like looking at your shapes and kind of thinking about those shapes in terms of other polygons that you're used to. Now let's do a little bit of review of parallel and perpendicular lines. Let me zoom out a little here. Okay. So as far as parallel lines are concerned, yes, parallel lines never ever touch each other. Now I've given you the equations of the 3 lines here. And just as a little review, let's find some colors. I'm going to use a couple highlighters. Actually 3, because I have 3 different colors, or 3 different lines here. So y equals 2x minus 3. Remember, that's your y-intercept, right? That last line there is your y-intercept. So this yellow line right here, this bottom line, that's your y equals 2x minus 3. Now you can see the y-intercept of the next line is 1. Well, the y-intercept on this line here is 1, so that next line is going to be this one. And then my last line, my last equation, I should say, has a y-intercept of positive 5. Well, that coordinates with this one, which has a y-coordinate of positive 5. So that's my pink one. Now just by looking at the equations, or just by looking at the lines, either way, I can always find the slope of lines. So the slope, remember, let me write it right here. Okay, so we just talked about the y-intercept, so your b is always your y-intercept, meaning the place where it intersects the y-axis. And then this number right here, the coefficient of x, is always your slope. So what I notice about each one of these lines is that they have slopes of 2. And I could calculate that just by finding a couple of points. Let's see. If I went from example 0, -3 up to 2, 1. So that's a rise of, let's see, 1, 2, 3, 4. And that's a run of, really that's 2 because these units here on the x-axis are going by 2's. So I can say that my slope is a rise of 4 over a run of 2, or that's just 2. And I can do that for every single one. But I've been given the equations, and you can see that the slopes in these equations are all 2. So I know for a fact that these 3 lines are parallel, not because they look like they never touch, but because their slopes are exactly the same. Their slopes are equal. So parallel lines have equal slopes. Okay, well actually, we'll go to the next page in a minute. Now, I've given you some perpendicular lines, and I know that they're perpendicular, well, for a couple of reasons. One, somebody drew on here a little right angle box. So I know that a right angle has been formed. Also, I can compare their slopes. So if I look at the slope of this first line, well, the slope here is 3. Okay, so let's see. I'm just going to put it up here. So the slope here is 3. And if I look at, and how about I highlight? Because color is always fun. And then my second line, the slope of this line is -1/3. Actually, let me highlight those slopes too so that they kind of stand out to us and they are coordinated with their lines. Okay, so I know just by looking at the slopes that these lines are perpendicular. So I don't actually have to see that little right angle. Just by looking at the slopes, what do you notice about these? Well, one, they're opposites of each other, right? These are opposites. One's positive, one's negative. And the second part is that they're also reciprocals of each other. Notice this is 3/1 and this is 1/3. So perpendicular lines have opposite reciprocal slopes. Okay, so here, slopes are opposite reciprocals. Opposite reciprocals, that's an A. And here, slopes are the same. How about slopes are equal? So parallel lines have slopes that are equal. Perpendicular lines have slopes that are opposite reciprocals. Okay, let's move on to the next page and we'll kind of summarize that one more time. So parallel lines have equal slopes. Perpendicular lines have opposite reciprocal slopes. Now, sometimes what you'll see, instead of people saying opposite reciprocal, you'll say that they will say that the slopes of perpendicular lines multiply to give you 1, or the product of the slopes is equal to 1. Sorry, -1. Let me prove that to you. So we can say that this times this, the product, right? Or 3/1 times -1/3. The product of that is in fact -1. Right? These reduce and you're just left with -1/1, which is the same as -1. So sometimes some textbooks, they will say perpendicular lines, the slopes of those perpendicular lines, the product is equal to -1. That's another way. It's easier for me to just think opposite reciprocals because if I know one, then I just go opposite. So if I knew this one, I'd say, okay, it's the opposite, so it's got to be positive, and it's the reciprocal of that, so it's +3. Instead of thinking to myself, what number times -1/3 will equal -1? But you can think of it either way. And you may have learned it the other way at some other point in time. Now, horizontal lines. So horizontal are lines that look like this. This is a horizontal line. That's a horizontal line. So all horizontal lines are parallel. Right? They're never going to touch. Vertical lines. So vertical lines look like this. These right here are vertical. And all vertical lines are also parallel. That becomes important because we're going to talk about the equations of horizontal lines and vertical lines, and their slopes are actually quite interesting. So we'll talk more about that later. It's hard to compare the slopes, so I just wanted to let you know that all horizontal lines are parallel, all vertical lines are parallel. Now, what do you think is true about a horizontal line and a vertical line? Well, a horizontal line and a vertical line are perpendicular. Therefore, they have opposite reciprocal slopes. I didn't give us very much line. I didn't give us another line. Darn it. Okay. They have opposite. We'll just put it right here. Reciprocal slopes. And it's actually going to be kind of interesting because they don't really have opposite reciprocal slopes, but just think of it that way. Okay? For now. And then we'll talk more about it later on. So all perpendicular lines have opposite reciprocal slopes. And it will look opposite reciprocal. It's just going to look really strange when we actually talk about the slopes of horizontal and vertical lines. All right, moving on. So let's do our first problem here is an exploration out of your book. We're going to find the perimeter of quadrilateral ABCD. So this is quadrilateral ABCD. We just name polygons by their vertices. Okay. So some quadrilateral. Okay, so we're going to find the perimeter. So in order to do that, I actually have to find the length of every single side. Well, maybe you noticed that to get from B to A, I had to rise up 1, 2, 3 and go over 1, 2, 3, 4. Right? So my rise here is 3. My run here is 4. So I can use distance formula between these two, or since it's already graphed, I can figure out the change in the y. So the change in the y, right, the 4 minus 1 is in fact 3. And then I can also figure out the change in the x. Well, that change in the x goes from -3 to 1, which in fact is the length of 4. And so now I can find that hypotenuse, or AB, pretty quickly. I can kind of skip the x2 minus x1, right? So again, if I were to do the difference between the x's, it's just 4. So it's 4 squared plus, and if I was to do the difference in the y's, it's just 3. Really what I've done here is I've kind of combined Pythagorean theorem and distance formula, which again, they're the exact same thing. Okay, so AB, I noticed, is going to be 16, the square root of 16 plus 9. Or in other words, the square root of 25. So we know that AB is 5. Now, I would not do this triangle, like I would not graph this out normally. I would just find the length of that if it was not already graphed out. Okay? All right, so now let's do the same thing between C and D. Let's see. So to go from C to D, I would have to go up 1, 2, 3, or maybe I can go over here on the side. Go up 3. And I would also have to go over 4, right? Does that make sense? In this case, though, no, it's still a positive slope. So you notice that these dimensions, the change in the y and the change in the x, are exactly the same as AB. So we know that CD is exactly the same length. CD is also going to equal 5. You can do the math again if you want, but you don't have to. All right, let's compare the slopes now of for B and C and AD. So let's see. There's a rise of 1, 2, 3, 4. There's a run of 3. Now this is a negative slope because I went down 4, right? So it's a negative 4/3. So there's a rise of negative 4 because I went down. This is also, if you just look at this line from left to right, if you were standing up here, you could roll down the hill. Okay, and the same thing here, it's also going to be a negative slope, so let's see what we got here. So I've got a rise, right? So going from here down to here, it's going to be negative 4, and a run of 3. Okay, but the lengths of these sides, right? So the change in the y's is still a total and absolute value of 4. And if I square that, I'm still going to get that 16. And the same thing with my run here, right? It's still a run of 3, so when I square that, I'm going to get 9. So guess what? BC and AD are also going to be 5. So I know all 4 sides are 5. Okay, so find the perimeter of quadrilateral ABCD. Well, basically the perimeter will now equal, well, you just add up all the sides to get perimeter. 5 plus 5 plus 5 plus 5. Or in other words, it's 4 5. So you can do 4 times 5 and get 20. Now for perimeter, I mean, you weren't given any units here. Usually it's linear. Whatever the units are, they're linear. So this is just going to be whatever the units are. Meaning we don't square them, we don't cube them. Okay, so it's 20 units. So we found the perimeter. And we didn't have to do a whole bunch of math where we had to find the length of every single side, because we kind of just used these slopes to see, oh yeah, they're all going to have the exact same length, the exact same hypotenuse. You could have done this for every single one, but you didn't need to. Okay, now are adjacent sides of quadrilateral ABCD perpendicular to each other? Okay, well, what we're going to do for this, to see if they're perpendicular, we're going to go right back to this, what we talked about here, and we're going to compare their slopes and see if they're opposite reciprocals. Now, adjacent means right next to each other, so they're touching each other. Okay, so I'm going to do the slopes. Let's see, how about the slope of AB? So I do a little m for slope, and then I do a subscript of segment AB. So that means the slope of segment AB. So the slope of segment AB, again, rise over run, is 3/4. Now the adjacent sides to this segment are BC. So let's find the slope of segment BC. So the slope of segment BC, well, our rise now is -4 and our run is 3. So it's -4 over 3. So just as a reminder, maybe I can write it over here. Slope, oh, you know what? Let me write that a little bit more to the left. Slope is equal to rise over run. Slope is very important in math. It actually is the backbone of calculus. So right now, we're just doing some calculus is all we're doing. Pretty cool. All right. So what can we tell here? So if I take segment AB slope and segment BC slope and I compare them, I notice that they're opposite because this one's positive and this one's negative, and they're also reciprocals, right? So I know that segment BC or segment AB is perpendicular to segment BC. Okay, let's do another pair of adjacent sides. So let's see, well, we had AB over here. So how about now we compare it with AD? So again, the slope of segment AD, we've already got the slope of segment AB. Slope of segment AD, well, my rise, again, going from left to right, it goes down, right? So it's a -4 over 3. So then I also know that segment AB is perpendicular to segment BC because, again, they have opposite reciprocal slopes, right? These are opposite reciprocals. And the only other one I need to compare now is CD. So let's look at the slope of CD. I'm going to put that over here. Slope of segment CD. The reason I'm putting it over here is because it's directly opposite of segment AB. Okay, so let's see if they have anything the same. Let's see. So to go from C to D, I had to rise up 3, and I had to run over 4. Does that make sense? So to go from C, maybe it would help if I did it over on this side. Went up 3 and went over 4. So again, that slope is also going to be 3/4. So we know then that segment CD is also perpendicular to segment BC, and segment CD is also perpendicular to segment, oops, I wrote this twice. Sorry guys. That was segment 80. This would be segment 80. Right, so I know that segment CD is also perpendicular to segment AD, and it's perpendicular to segment BC. How can I tell? Okay, so I can say that I know this because slopes are opposite reciprocals. So I'm just going to do this for all of them. Slopes are opposite reciprocals. All right, so what do I know now? Well, I know that I have right angles at every one of these corners, right? Because these are all perpendicular segments. All adjacent segments are perpendicular. I also know that all my sides are congruent, right? Because we found that back here. All sides are congruent. Pretty cool. So then what shape do we have? Well, let's go to number 3. Is quadrilateral ABCD a square? Heck yeah, it is, right? We got 4 right angles and 4 congruent sides. So justify your answer. So we'll say yes. We have 4 congruent sides and 4 right angles. So now we can find the area. Well, the area of any square, you can basically multiply base times height, but since squares all have the exact same side lengths for every single side, you can just do side squared. So the area here, well, one of our sides is 5, right? So 5 squared. So our area will be 25. We don't know what the units are. I'll put units, but they're square units. Because if it was like feet, for example, well, you'd multiply the 5s and you get 25. And what happens when you multiply feet by feet? You get feet squared. So that's just why. All right. Moving on. Polygons. So we're going to name some polygons today. In geometry, a figure that lies in a plane is called a plane figure. So that means that they're 2-dimensional. They're not 3-dimensional. Remember, imagine like a plane like your desk, right? It's just this flat thing. It doesn't pop up at all. It doesn't project out at you. Recall that I should say that the top of your desk, right? Think of it like a piece of paper. It's just, there's no real thickness to a piece of paper. Recall that a polygon is a closed plane figure formed by 3 or more line segments called sides. So you got to have at least 3. Otherwise, you're not going to have a polygon. It's not going to be closed. It's got to be closed. Each side intersects exactly 2 sides, one at each vertex. Now, that's an important word. So vertex is a very important word. So each side intersects exactly 2 sides, one at each vertex, so that no 2 sides with a common vertex are collinear. Okay, so no 2 sides, for example, A is a vertex, or here, let's use D. D is a vertex, which makes CD and segment DE, they're not collinear, or I should say, you can imagine these as lines going on forever. So line CD and line DE are not on the same line. They intersect at this vertex. You can name a polygon by listing the vertices in consecutive order, just like we did on that last exploration, right? It was quadrilateral ABCD, right? This was quadrilateral ABCD. So we just took those vertices, A, B, C, D, and that's how we named our quadrilateral. Okay, this is how many sides? 1, 2, 3, 4, 5. So this is a pentagon. So we could name this pentagon A, B, C, D, E. Consecutive means you go in order. So if a polygon has 3 sides, we've always called that a triangle. If it has 4 sides, yes, a square is a type of quadrilateral, but there are other types of quadrilaterals. So if it has 4 sides, we call it a quadrilateral. And we will talk about different types of quadrilaterals eventually. 5 sides is a pentagon. There's actually a building in Washington, D.C. called the Pentagon. It actually is built like a pentagon. A pentagram has like 5 corners. That's a star. Okay, so pent means 5. Okay, 6, well, we dealt with that earlier. That was a hexagon. We divided that up into 6 triangles. 7 is a heptagon. 8 is an octagon. All of these are like prefixes that apply to other things, like octopus has 8 arms. Okay, 9 is a nonagon. 10 is a decagon. 12 is a dodecagon. Dodecagon. And anything I haven't listed here, we basically use n for. So, for example, well, here, let me do this. It's going to be an n-gon. But what if I gave you a 53-sided figure? Well, that would suck to have to count up all the sides. But we'd basically call that a 53-gon. Notice I don't have an 11 in here, so we'll call that an 11-gon. There is a name for it. I don't know what it is, but our textbook doesn't recognize that. So probably the biggest one you're going to need to define is a dodecagon. Other than that, it'll just be n-gon. Or like 53-gon, 11-gon. Okay, moving on to convex versus concave. So concave, basically, like if you think of like something caving in on itself, that's kind of how I think about concave. Okay, you can see like this piece here, like maybe there used to be a line that joined these to a straight line, but now it's been caved in. Okay, so that's my best explanation there. A polygon is convex when no line that contains the side of the polygon contains a point in the interior of the polygon. So I like to use rulers for this. So if I connect any 2 vertices with a line, notice I don't go actually inside. I'm sorry, I should say 2 consecutive sides. I don't go inside, or 2 consecutive vertices. I don't go inside the polygon. Right? So if I just use a ruler and I go along and I connect all of the vertices, so all the sides, right? Connecting vertices basically gives us the sides. I never go inside the polygon. Now if I go to this one and I connect consecutive vertices, for example, maybe this vertex and this vertex, notice what would happen. My ruler is going to go straight through the interior of the polygon. That's what they did here, right? So when they were connecting this vertex and this vertex, notice that line right there? Connecting those with a straight, with a line that goes on forever, goes right through the interior of the polygon. So that's the difference between a convex polygon and a concave. Here, any of the sides, I can connect 2 vertices. That side never goes through the interior, right? The line connecting those 2 vertices never goes through the interior. Here, connect 2 consecutive vertices to make a side. Well, the line does go through the interior right here. So that is the difference between a convex and a concave polygon. I would just have examples of those on your note card. Like, I wouldn't worry too much about spending a lot of time memorizing those. I just put that on your note card. I don't think it's a huge deal, but I do think it's important when we're talking about, regular polygons. We always talk about like convex polygons, and you'll learn more about that later, not concave polygons. So I guess let's highlight this. Convex, when no line that contains a side contains a point in the interior of the polygon. And again, I remember, it looks like somebody punched that in there, right? Punched in the side. I'm not a violent person, but that just is what that looks like. So we'll classify each polygon by the number of sides and then tell whether it is convex or concave. So I'll go through. Sometimes it's nice to kind of start somewhere, like put a point where you're starting. So this is 1 side, 2 sides, 3 sides, 4 sides, 5 sides. So 5 sides means that it is a pentagon. Now, is it concave or convex? So I guess take your ruler along the sides and see, hey, if I go along these sides, if I think about a line going along these sides, would any of those lines ever go into the inside of the polygon? And in this case, it would not. So this is a convex polygon. Okay, let's see. I'm going to start over here. Doesn't matter where you start. Just make sure that you know where you started so you know where to end. So the number of sides, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I got 12 sides. We call that a dodecagon. If you don't know the names of these polygons, you're going to want to learn them. It's basic vocabulary. And now if I connect some sides, well, let's put a line through that side, right? It doesn't go through the interior. But what happens when I put a line, for example, through this side? Notice that this line will go right through the interior. So I know that that's a concave polygon. In other words, maybe there was a side here that somebody punched in, right? So it's going inside, right? You can connect any 2 vertices here. The line that goes through them is going to end up inside the polygon. So we've already gone over these, but we'll just quickly highlight them again. So the area of a triangle is always 1/2 base times height. Perimeter of any figures always add up all the sides. So you have 3 sides. You have 3 exterior sides. You add those up. One other thing I should remind you of, height and base always have to be perpendicular to each other. Perimeter for a square where every single side is exactly the same, so it's just 4 times the side. Or you can just go side plus side plus side plus side. And then area, well, again, the sides are the same. You can think of this as like base and height. Either way, take a side square. That's the area. Rectangle, perimeter. So again, you can just add up all the sides, but opposite sides are going to be congruent. So you can basically do, 2 times the length, which those are the same, and 2 times the width because those are the same. Or you can just say length plus width plus width. It's exactly the same. And area is length times width or base times height. Just make sure that they're perpendicular to each other. So perimeter has, and we've already talked about this, linear units, such as, let's just use feet. While area has square units, such as square feet or feet squared. These, when you read this, it's really square feet. And I did that example on the other page. All right, so if you just want to find the perimeter of triangle PQR, well, truly, I know what this looks like. This is a triangle. P connects to Q. Q connects to R, and R connects right back to P. Let's see. I think these two right here, right, they have the exact same x coordinates, making this a vertical line. Okay, so I can find the length. Let's start with that. I'll find the length of QR. Now QR, oops, I'm just going to write a little note to you here. I know that this is a vertical line. And that's because we have the same x coordinates. You can draw this out if it makes you feel better, but you don't have to. Okay, so finding QR, basically if I have the same x coordinates, I'm just going to go ahead and subtract and take the absolute value of my y coordinates. So the absolute value of 4 minus a negative 1. Or in other words, that's the absolute value of, well, minus a negative is really positive. So absolute value of 5, which is just 5. Okay, so I know QR, got that really quickly. Let's look at PR. Oops, nope, those are not the same. Oh, how about PQ? PQ has the same y coordinates. Okay, so let's do the same thing here. So PQ has the same y coordinates, making this a horizontal line, right? So we know that this is a horizontal line because we have the same y coordinates. So to find the length of PQ, all I have to do is subtract the x coordinates. So we'll do negative 1 minus 2. Order doesn't matter because even if it's negative, it's going to become positive because we're using absolute value. So that's an absolute value of negative 3, or in other words, 3. Okay, and then the last one, so let's see, I've got QR, I've got PQ, so I think I'm missing PR. Now those don't have anything that's the same. No x coordinates that are the same, no y coordinates that are the same. So the way I'm going to find the length of that is to basically use the distance formula. Okay, so let's see. So we'll go PR is equal to, and that's where you basically say, okay, I got one of these as my first point, one of them is my second point, and I'm going to use the distance formula. So change in the x's, so I can go 2 minus negative 1 and square that. Change in the y's, I'll do negative 1 minus 4 and square that. Okay, so that's going to give me 2 minus a negative, well, that's going to be plus, right? So 2 plus 1 is 3 squared. Negative 1 minus 4 is negative 5 squared. So this is 9 plus 25, or is that the square root of 34? Now 34, factors of 34 are really 17 and 2. Notice neither one of those are perfect squares, so I can't simplify that anymore. This is as simple as that's going to get. Okay, so let's find the perimeter. So the perimeter will equal, let's see, it's going to be 5 plus 3 plus the square root of 34. Okay, now think of the 34 kind of like a variable, like an x. Like, for example, if I had 5 plus 3 plus x, I would add these two together and I would just add x at the end and it wouldn't combine with these at all. That's very similar to radicals. Radicals, just kind of think of them as, unless you have the exact same radical, they can't be added. So this is going to be 8 plus the square root of 34. So I don't know what these are measured in, so this is just going to be units. Okay, moving on. Oh, why did I erase that? Okay, moving on, sorry. Example 3, we're going to find the area and the coordinate plane. So find the area of triangle ABC. Okay, so the area of any triangle is 1/2 base times height. Or base times height divided by 2, that's the same thing. And the key here is we have to figure out what the base is, we have to figure out what the height is. Let's see here. So when I look at this, I notice that I have two y values that are the same, which means that BC is going to be a horizontal line. Other than that, I don't see anything else that's the same. So this one's a little perplexing for me, so I'm going to go ahead and graph this out. I think we're going to probably have to draw in our own height. You can use graph paper if you want, or just in our notes, we'll try and be really nice and neat about it. Okay, so I'm going to go back. Let's see, for A, sorry. I'm going to start at the origin. I'm going to go over 1 and up 3. So A is the point 1, 3. B is the point 3, negative 3. So I'm going to go 1, 2, 3, and then down 1, 2, 3. And then C is the point negative 2, negative 3. So I'm going to go back negative 2 and down negative 3. Oops, and I should label these. So this is B, which is 3, negative 3, and this is C, which is negative 2, negative 3. Okay, so let's connect these. So my base is very obvious. My base is that horizontal line, and that is BC, right? And I know that the length of BC is basically going to be the absolute value of the difference of the x's. So negative 2 minus 3 gives us the absolute value of negative 5. Oops, I'm off the screen. So that's my base, which is going to be 5. But now what's my height? Okay, so this is my base. Well, my height wasn't given to me right off the bat. I have to actually draw it in. So what I'm going to do is I'm going to go from the vertex, from a vertex, opposite the base, and I'm going to draw in my own perpendicular line. So that is a vertical line, which is going to be perpendicular to my base. Well, I know that, the y value here was up to 3, and the y value down here is negative 3. So, oh, and I should have called that A. Let me go ahead and call this point D. So my height is going to come from finding the length of AD. I just gave it some random letter, that height that I drew. I just drew it to some random letter, some random point there. But again, it has to be perpendicular. So the height for AD, just change in y's, right? Just this 3 down to this negative 3. So it's 3 minus negative 3, or the absolute value of that. Well, that's the same thing as 3 plus 3. So it's the absolute value of 6, which in fact is 6. So my height is 6. So for my area, if I go back up here to this formula, well, my base was 5, my height was 6, and I'm going to divide by 2. That's just part of the formula. Now I'm going to reduce before I multiply, because it's easier for me to reduce before I multiply. So 2 goes into 6 3 times, and that gives us 15. Now, I don't know the units, so I'll call this units squared or square unit.